Welcome to another example of the central limit theorem. I chose this question because it has one thing that none of the other questions does. It does not say normally distributed. In fact, it says, this will let me, oh, there we go, skewed left. So it is not normally distributed. But both questions ask about means. What is the probability of the average? And then both questions have n greater than 30. In part A, it's 50, and then part B is equal to 30. So in both cases, you can use the central limit theorem and say that the sampling distribution is normally distributed, even though the population, the parent distribution, is not. With a mean of 68, and then part A, the probability of the average age will be more than 70, or less than 65. So more than 70 or less than 65. So we're looking for the probability that not x, but x bar is less than 65 or x bar is greater than 70. And we'll use the addition principle. And then we'll also use the complement rule, and I'll use that while I write out my Excel commands. So the first one, norm dist of 65, 68, and it's not 7, it is 7 over square root of 50, because it asked about the average. Then the 1 minus norm dot dist of 70, 68. And again, we have to adjust that standard deviation. And I'll calculate that in a moment. So part B again is going to be, even though the parent distribution is skewed, the sampling distribution is going to be bell-shaped normal with a mean of 68. In this case, the question says the average age will be more than 66, but less than 71. So that would be in between. And again, it's not x, it's x bar. And we'll use our between rule. Again, we have to adjust our standard deviation, but this time it is 7 divided by the square root of 30. So let's calculate both of these. Part A, norm dot dist, 70, 68, 7 over square root of 50. True, plus 1 minus norm dot dist of 70, 68, 7 over root 50. True. And it says 1, which is very fishy. I don't believe it to actually be 1. I believe it might be close to 1. Let's find out what it is. And apparently it is very close to 1. So I'll leave it at 1. We'll double check what I typed in. Oh, and I mistyped. It should have been a 65. That sounds like a much better answer. This time our standard deviation is 7 over root 30. Or 0.9317. Said at the beginning, the main reason to do this was to indicate that just because it says skewed, that's okay. Also to let you see that in part A and part B, the n can change and the standard deviation can change, or the standard error of the mean can change, that is okay. As always, if you have questions, please ask your instructor.